Alright guys, we'll do this and then we'll take a break. Just to give you a little hope. Sorry, I'll take a person. I'm not a teacher, I'm a student. Create a frequency distribution. So we have to get a class width. We already did the width up there on the board. That was 9. And then when I go to set up my classes, you do it the book way, add 9. So this has got to be 64. Now I just keep adding 9 on both sides. You can do it, Chef. This will be, did I do that right? Yeah. 92 up to 100. If you did the inequality way, should be okay. Now, if we're going to count these, let's see. Well, let's see. I think everybody pretty much got this. There's just 3, right?
Yeah.
3, 9.
2.
All right. It's a pretty boring distribution. So this is the frequency. You didn't have to do anything else on this problem. All I wanted was a frequency distribution done and a frequency histogram. So this axis is going to be based on these numbers. So I'm going to do 2, 4, 6, 8, 10. That's the frequency. And then since I picked this way, what do I have to put down here? 55.5. If you did inequality way, you're allowed to use whole numbers. If you didn't, too damn bad. Right? So you pick a way you like, and you have to complete that way. You can't suddenly change ways in the middle. Well, I guess I can. Well, then I'll take one. Now I just keep adding 9 because that's how wide each rectangle is. I like it. So for those of you that did the inequality way, what's your highest number?
101.
101. In fact, most often this highest number will not be the highest data point. If that happens, that most of the time means you forced it and you made that last rectangle tinier, and that ain't fair. Poor little thing. When every rectangle has the same width. And now I'll just make my rectangles as tall as they are supposed to be for each class. So this goes up to 3, this goes up to 9. They come there. Rock. This goes up to 3, and another 3, and then 2. Now what goes down here? Quiz 1 grades, I like it. And there you go. Done. I like it. So if that bar was went over, it would look like the graph was flicking us off. But nope, it's pointing us somewhere. Over there. Alright. Is everybody cool with that part? Okay. P17, the first step would be and then what do you do with this? Always force it up. Why? Why? Because if I go to the 3.4th number, is there a 3.4th number? No, screw that. But if I go there, I have 17% below. So if I go to 3, do I still have 17% below? No. That's why we always round it up. All right, the below part is the slightly more important part.
Going back to A real quick, the graph, the table that we set up.
Yep.
What do we put at the inequalities? Do we put nothing,
Oh.
classes, grades? Does it specify what we have to put?
Where do you mean?
Where you say where you have the width, see where the width, and you left it empty, right?
Yeah, you could put classes here. It doesn't really matter.
Okay.
Yeah, it's not really necessary. It's always going to be the classes. So you almost don't have to put a label for it. I like it. Huh?
You said almost. You almost don't have to put so.
You never do.
Okay.
Never. It's just a habit of mine to never say never. But you never do. Well, unless you take someone after me and they want you to. So therefore, almost never. For me, you never do. Yes.
So if you go to 4, isn't that like if you round it to 4, you still won't have exactly 17%, below, you'll have like a little bit more.
All right.
So
Hold me
is
on.
that better?
So, you ready?
Okay.
You ready? There are much more complicated ways. If you have a small set of data, asking a specific like this is kind of silly in itself because the 17th percentile is the same as the 18th. It's the same as the 19th for a small set of data. If you have a huge set of data, then there's so many numbers, there will be exactly a 17th percentile and exactly an 18th percentile. If I have a huge set of data, are you with me? I really want this to make sense. If I have a small set of data, is there enough data to be every single possible percentile? No. There's not enough to go around for all 100 percentiles, right? In fact, I could do the 12.7th percentile, and we're not going to. Don't forget. So for a small set of data, I can't be that specific anyway, so the rounding doesn't matter. For a huge set of data, the rounding doesn't affect anything because there's so many data points, everybody's going to get its own position. So there are more specific and more complicated ways to do this, but they don't do anything better for a small set of data. And for a big set of data, this rounding doesn't do shit anyway. There's so many data points, I'm going to get them. I've got enough to go around for everybody. Does that make sense?
Yeah, but like the thing is that I'm confused about is if you were to do 3 as opposed to 4, I'm just trying to figure out why it's like significant. So like you said,
Because then you don't have this much below it.
But then even if you do to 4, then you still don't have 17. But you have like 17 and then
You have closer to 17%. So let me see. So if you do the third data point, how many data points are below it? So the third data, there's 2 data points below it, right? 2 out of 20 is 10%. Right? If I do the fourth data point, there's 3. What's 3 out of 20? 15%. Which one's closer to 17%? This one.
But it's,
And-
yeah, but the thing is that I'm confused that it's still not 17. So that doesn't matter at all, or?
So I really want you. So if I have 20 data points, right? All right, let me see if I can, I don't know. If I have 20 data points, there will automatically have to be a bunch of repeats for any percentile I want, because I only have 20 numbers. And how many whole number percentiles are there? 100. Right? So I'll bet you anything that P51 is the same thing as P52 for a small set of data. Okay, I like it. So you're never going to get exactly 17% below for a small set of data. For a huge set of data, you will be able to get exactly 17% below. And this method will still get you there. So if I had 100 data points, right? And I want to get P17 for 100 data points. You guys with me? Anybody still paying attention? Okay. If n is 100, if I have 100 data points, how do I get P17? 17% of 100 is 17, right? And then what will I do to get P17 then?
Choose the
17th and 18th. Right? I like it. So this would have 17 data points, and here's a 17.5. Is that cool for me? The 17.5 is the one right between the 17th and the 18th. So it has 17 below it. Out of 100, 17%. So the bigger my sample gets, the more data points I have to match up with each percentile that I want. I've only got 20 numbers. P17 is going to equal P18, is going to equal P19. They're all going to be the same damn thing because there's only 20 numbers. How could I have a different number for each? I can't. Okay. Maybe? You guys with me? No? The break is coming.
Maybe it's like 4 includes 17%. You know what I mean? Like, I don't know. That's kind of how I think about it. It's like it includes 17% as well as a little bit more. You know what I mean?
No.
Do you know? Okay.
That's all right. Again, it's because when the sample is so small, which is what we're going to be mostly working with, right? As small samples, you are welcome. You get a little bit of weirdness because there's not enough data points to go around. If we had a sample of 900, none of this weirdness would happen because there's so many data points that could be very precise. I really want you guys to get this. No? Yes? Maybe? So if I have more data points, which we will not have because I'm not going to give you 800 data points to make a busy work problem. 800 data points. But a lot of the weirdness we see is because we're using such a small sample, there's not enough data points to go around to be exactly the 17th. There's not another data point to be the 18th. There's not that many. So there's going to be one guy that's a lot of them because there's only so many to choose from. Yeah.
So for this one, it's 4, and you don't.
I haven't done the next step yet.
Okay.
I'm not done. I got sidetracked. So what is the answer then? Yeah, the fourth number, which was 65? Okay. Okay, I like it. And then to do P72, 72% of 20. 14.4. So the answer is going to be the 15th number. What's the 15th number? Yeah, I like it. Yes?
Okay, so for instance, I put the relatively information, the relatively frequency information on my graph. Are you gonna mark that wrong if I did that on a test? Since I went
Oh, you
through-
put it here?
Yeah.
And this was based on percentages? Then I would mark it wrong. But, I mean, this problem will be broken down into parts. I do give partial credit, which is why I say show
I
you.
just did it like that, but I didn't know. Well, I know that.
Why would I
it's-
take points off if you put percentages here, relative frequency here? Because what did I ask for? Frequency histogram. I like it. And it's really funny, when I say something like that, I always feel like somebody out there is like, what an asshole. But I asked for a frequency histogram, you better give me one. If you give me one that's not quite that, you're gonna lose a point, right? Nothing
I
major.
did it like that first, and then I saw my worksheet, and then yesterday you asked us for the other one.
There you
I
go.
got all confused.
I understand. No confusion there, right? What kind do you make? Well, do the one I asked for. So if I say frequency, this is going to be the whole numbers. Relative frequency, this is going to be the percentages. That's all. Yeah. Anything else? You guys all right? Okay. So what does this mean? What does the 35th percentile always mean, but then bring in the actual physical situation? 35th percentile always means what? That data point had 35% of the data below it. I love you guys. Yes? This is what we have been saying. What does the 35th percentile always mean? I don't care what the data is. That data point had 35% of the other data below it. Now, don't say that for this problem. What's the data? Grades. So if you're at the 35th percentile, you scored higher than 35% of the people, 35% of the grades were below yours. There's a lot of different ways to say it because we have an English language and you can reference the situation in multiple ways. You guys with me? Yes. So you understand what a percentile means always, and then you can adjust it to make sense in English for what the situation is. So either way, you can say I scored better than 35% of other people. Or you could say my grade is higher than 35% of the other grades. It's basically saying the same thing. Yes? Oh, not really, because that would just be subtracting, give me the answer. Nothing interesting there, right? Okay.
Could you phrase it in the sense of 35% of others score lower than you?
Yeah.
Rather than.
Yeah, totally, yes. Yeah, I scored higher than them, so they scored lower than me. It's yeah, I like it. Sure, I would accept that. That's fine. But what does a P35 tell you directly? Something about 35% somewhere, right? I'm trying to make that a little bit of a point because it's going to relate later to something we do where we're going to use a chart that's always going to tell us below stuff. But I would accept that because that is what that leads to. I like it. I like it. And you're all like, we're not sure yet. Or I am sure I hate it. Okay, shoot. All right, here's the new stuff. We're gonna do this by hand, and I'm gonna show you how to check your work on the calculator. Some of you guys unfortunately know some of the buttons, and you're gonna hate me, and I don't care. If your calculator doesn't work, it gets to graduate. It gets to go have a great life. It has multiple calculator babies. It's a great life, and you're stuck retaking the class. And I don't care if you don't find it funny, but I do a lot of stuff by hand, and I do show you how to check it. And there's some stuff we do by hand that I eventually let you just use the calculator for, but you ain't learning shit if you're just learning buttons to push. Right? I'm all about understanding ideas, right? So what's the 5-number summary? Yeah, the low is 56. The high is 90. What was it? 98. Yeah. That poor 98 person. Don't forget about that. And I had something interesting happen where a lot of you guys were like, well, what are these numbers? These numbers that have shit to do with this. Because what is Q1?
74.5.
No, I mean, what is the idea of Q1?
25%.
And then how do you find it? 25% of 20 is 1/4 of 20 is 5. So then how do I get the answer? The 5th and 6th numbers, what were those? 67 and 68. You don't even have to do this work, hopefully, right? What's in between 67 and 68? 67.5. Kick ass. I need to see this work. If the numbers show up out of nowhere, I don't care that they're right. I don't know if you did it. So you're going to lose points. Q2, the same idea. So half of 20 is 10. So I want to take the 10th and the 11th numbers. What were those? 73 and 73. Kick ass. It's always nice when they're the same. And then Q3, 75% of 20. 15, so I want to take the 15th and 16th. What were those? 81 and 85. And you get 83. Yes. So before we make the box plot, let me show you how to check that in the calculator. Okay? So if you haven't put the data in, all right, just watch. If you have put it in there, go along with me. Hit stat. I want to calculate something. How many variables are involved here? I've asked this question before. Let me see who says the wrong thing. How many variables do I have?
20.
No, I have 20 values. How many variables do I have? 1. How many values does that one variable have? 20. I love it. You guys get that. I have one variable, grades on quiz 1. If another variable was each person and how much they drank last night, that would be 2 variables. So why am I making a big deal out of this? Well, which one do I want it to calculate? I want it to calculate statistics based on one variable. Now, depending on which flavor calculator you have, if you have an older one, it doesn't show this, right? Is everybody with me on this? Some of you guys have this showing up on your screen, right? Some of you guys, you just have this word showing up on your screen? Or do you just not want to tell me? I ain't telling you shit, Jeff. Huh? You just have the word. If you just have the word, it defaults to list 1. You just hit enter. The rest of you make sure you have L1 and these are blank, right? Or this one's blank. You hit enter. So if you have this, you got a little more work to do. Enter, calculate. All right, let me see if you guys get all this. Don't worry, I'm going to show you. So there's a lot of stuff we haven't learned yet up here. We don't know what that symbol is yet. I don't know if any of you know what that symbol is. That stands for the sum. We're going to do that here in a bit. These we don't have a clue about. What's this? Yeah, so n is always the number. that I'm working with. The total number of things. I got 20 data points, right? 20 grades. Oh, look, there's the low, there's Q1. So if you scroll down, the last thing it tells you, the 5-number summary. Is that what we got? Hey, the calculator's right. It's always good to make sure the calculator's batteries are good and all that kind of shit. They got it right. Kick ass calculator. You guys with me? If you don't like what we just did, don't do it. Never do it. That's fantastic. Actually, to be honest, you are going to have to be able to do this one of our stats eventually. Because we're going to use some of this stuff. We're going to calculate this by hand first, and then later I'm going to let you just pick it out of the calculator because we're going to have other shit to do with it. So now let's make this box plot. I haven't really left myself much room. Let me do it this way. So I want to be able to go from 56 up to 98. So maybe I'll start at 55. This thing's going to drive me crazy. And let's see, it's 55, 65, 75, 85, 95, 100. There you go, buddy. And now you just draw your lines in. So the low was 56. Q1 was 67.5. Q2 is 73. Q3 was 83. And the highest one was 98. So everybody should look roughly like that, based on what your scale was based on. You guys good? Yes.
I start from 10. Is that wrong or is that okay?
Sort of wrong. It's like here. Same reason we don't start at 10 here. You see what I'm saying? So you have to do that, because if I start at 55, the assumption is there was nothing to see below that. So I'm not being misleading or dishonest. So I'd rather you not, so then you have more room to really blow up where the data is. I like it. Because I don't want, I see sometimes get this, I get a box plot like, I'm like, what the shit is that? Blow that sucker up. Or I love when I get a histogram like this. Because they went up to 100. You see what I'm saying? No, go up to the highest, and so you got more room for these guys to live in. So the guy grading your shit can see what you're doing. You might get more points for correct work. Okay, oh my God, let's take a break. Let's take a break, come back, let's see, come back at 11. Perfect. 11.